everybody, and welcome to another Desk of Lady Ada. It's me, Lady Ada. This is my desk. And today we're going to do a pretty chill build here. I just finished my last Feather, which is the Feather M0 with Wi-Fi. So it's a Cortex M0 processor with Wi-Fi built in. And so I'm going to get to the next one. It's actually kind of an older one that didn't get to kind of finishing up till now, which is the FONA Feather, which is an Atmega 32U4. It's kind of the same chip as the Arduino Micro or the Flora. In the Feather format, it's a little bit longer. It's kind of like a 1/4 inch longer than usual, but it has a cellular data and voice module on it and a little like cute micro SIM on the back, so you can pop in your SIM card like that, and then you can put an antenna on here. And you can use it for data or voice or SMS or GPRS. It's 2G, but you know, for a lot of people that's plenty good. And we sell 2G SIMs that work really well over the Ting network, so or the T-Mobile network using Ting as a carrier. And so this is the final prototype that we hand built. But when we actually go to manufacture, we have to make sure that all of them are built perfectly. And we can't solder headers to it and plug it in and try out all the stuff. Instead, what we do is we make a pogo pin bed tester. And what that does is it connects, instead of with soldered headers, it uses non-soldered connections. These are spring points that when you press the board down onto the bed, it touches all of the points you want to test. And then we write some software that tests the module. Sometimes we have another microcontroller or computer that tests the device. Like sometimes I'll use, if it's like a sensor or a breakout, I'll use an Arduino to test it because I have code already anyways. For the Feathers, what's really nice is because it has its own microcontroller on there, I use it to test itself. So I program the bootloader on, and then I bootload in a program that has it, actually use the cell phone module and make sure it can send an SMS and receive one, and it, the battery voltage is correct and all that good stuff. So this is the board we're going to do it with, and then I designed a tester, an Eagle, and I got prototypes made, lovely white PCB, and we're going to go to the overhead, the hover cam, and I can point out some things on it before we solder together. So, we on the hover cam? Okay. So yeah, so this is the board. So there's these row of pins over here, row of pins over here, and then there's like a cluster of pins over there as well. And so this is how the tester is designed. Basically, I take the board itself and then I just delete everything but the headers so that the headers are all in the right location, and I keep the board outline, and I leave the holes, the mounting holes. I'll use that for placement orientation. And then what I do is I connect opposite traces that on the board also are not adjacent pins, and I connect them together. And so what the microcontroller can do is test one pin and make sure it's connected to the other. And if it is connected, that means that there's an electrical path, through the chip, through the board, through the pogo pin, through the test PCB, and back up. Since the pins are not adjacent, there's no way for them to be shorted together other than through the PCB. So that's why you just have to make sure you don't try to do this with pins that could be shorted on the PCB, because then you wouldn't know if it was shorted over here or over here. So just pick, a kitty corner pads. And then the rest of the pads are actually used with the cellular module, and I test those. And then I have a little bit of components to help test like the battery voltage and such. Like for example, the 3.3 volt line goes through a resistor divider, and then I measure that on one of the analog pins on the 32U4, and that way I can like really easily test, what the voltage is, and I use the band gap voltage to verify it's the right voltage. So basically, you have it test itself. It's not so bad, and I've been doing it for quite a while. So once you use a USB-T to program in the bootloader, you just tell it, hey, run the test, and then print out okay if all passes. So what we're going to do is put pogos in here, and these are pogo pins. I got like a fun pack here. So pogo pins look like kind of like little spears or arrows, and they're springy. Inside is a little spring, and they're electrically connected, but they can bounce. So what happens is that if I have this in one of the pads and I solder it down, then when the PCB is held up against it, like so, it has a little bit of give. And that allows you to clamp it down and make sure you have a good solid connection. Another nice thing is that the radius of the body of the pogo pin fits like perfectly into these header slots, the header drill holes, but the head of the pogo pin is a little wider. So you can use, you know, the same size drills here as you would on the final device, and then like it, you know, it fits in the bottom, but it doesn't like pop through the top. I mean, if you have this is kind of like, I think, a spear point, and that's the kind of pogo pins I like the most. And then the only other difference is I made these oval instead of round. Like these were round, and I just made them oval because I wanted, you know, basically want to have as much mechanical strength as possible, and solder is good for mechanical strength. For these 4 pogos, I didn't have enough space, so they just made them round instead of oval. That's pretty much it. So let's get soldering. So I'll try to do this over here. So maybe, which do you think is better, on the overhead or the hover cam for soldering?
I think overhead.
Okay, I'll do the overhead, and then I'll show it off.
Yeah, just tell me, you can bounce between the two.
Yeah, I'm on the overhead right now. I'm gonna get my. I have to remember to call this the hover cam. This is the overhead, because now we have 2 top-down cams. Okay, so it's not too bad. You just want to basically get, and you know, pogo pins. You go through them a lot. So if you do get pogo pins, make sure to get plenty, because it's kind of hard to like, oh, you know, how will I need more than 10? But like this board uses 30. Like they go fast. So what I do is, it's actually hard to get them perfectly aligned. So I just do the best I can, and then when I get the final clamp in place, I align them against the clamp, because like these are a little crooked, and you know, honestly, that's okay. Like they don't have to be perfectly straight. You want to get them close, but it doesn't have to be perfect, because you can straighten them very easily later.
Yeah, if you look at the hover cam, by the way, too.
Yeah.
You can move things underneath it once in a while.
Yeah. I'll let me do these 5, and then I can show it off. So pretty easy. You just solder them in place. And sometimes we use milled PCBs, but for this one, I really need to get a finished PCB. A DIY PCB wasn't really good enough. Okay. All right, so then you can take this over to the hover cam. So yeah, it's not straight, but that's okay, because we'll straighten them later. We just want to get them in the right location, and then I'll pop them into place. I'll show you. It's very fun to do. You basically position this in the right location and clamp it down, and then you just pop these, and they clip into the exact right location. So it's fine that they're not even. Most important thing is to make sure you have plenty of solder, that they're mechanically strong. Kind of fun. Spoing, spoing, spoing. Okay, so do the rest.
While you're doing this,
Yeah.
one of the questions was, why white solder mask?
Every time I get prototypes, I change up the color so that I know which run it came from, because I am often, the way I panelize it, the way we do revisions on PCBs is there's actually a little object with the revision code on it, but when I panelize the PCBs, I copy and paste them into one large Eagle panel. So I lose the revision codes, and I can probably put on date codes and all that good stuff, but I just kind of never do. So instead, I just kind of switch off what color solder mask and silkscreen, and that helps me keep track of what run it came from, because like I named the run by the color of the PCB. It's just like a way for me to also take a look at, you know, what different colors look like. Like I was like, I've never tried white mask with blue silk, and now I know what it looks like. It's actually kind of nice. Okay. Remember, it's okay if they're crooked. Fix it up later. Fix it in post. Yeah, there you go. I'll try, maybe I'll solder the last bunch under the hover cam. You can see, and I got a bunch of pogos going on. So, yeah, I really like these. What's funny is I would buy these by the hundreds, and then I was like, you know what, I should just put them in the store, so I did.
Okay, so here's a question. When you make the board, you plan the test board for all test boards or just close to final rev?
What I usually do is I actually take one of the board that I'm testing, and I put headers into it, and I put it onto a solderless breadboard, and then I plan out my circuitry, like all the resistors and the diodes, and I solder wires, and I emulate the tester on a solderless breadboard to get the idea of like, okay, what will this test actually test everything? Because you can design the tester and it turned out that you're wrong. I've totally done it, and sometimes I'll just wing it. I'll be like, this is probably right, and I'll send it off, and I'll be like, I have to cut a trace and move it because I forgot that pin, you know, doesn't have a pull-up enabled or something. You know, and I needed it for the test I thought I was going to do. But if you sacrifice one board, plug it into a solderless breadboard, and do all the wiring you think you'll need, then you just duplicate it into EagleCAD. Okay, so.
Good answer.
What? Good answer? Okay, great. But for very simple breakouts, like for I2C sensors, I don't emulate it really. Like I just kind of wing it because I'm like, well, you know, the I2C pins are the I2C pins, and the power pins are the power pins. Like, you know, there's not GPIO and the IRQ. Like, there's not a lot going on because I test it functionally. For this, it's testing itself, so you have to be a little creative because you want to make sure that you test all the pin functions properly. Okay, so we're in a good spot. So yes, so here we got all the pogos, and they're soldered. They're crooked, but they're all in place, and the bottom is nice and flat. So now what we're going to do is we're going to do my favorite thing, which is you add, yeah, it's been a while since I've done this, but you add bumpers. So to make it so it doesn't slip around, I got a slippery desk. And then you get some Kapton tape. Kapton tape is nice because it's heat resistant. So when you're soldering, it doesn't melt. But you're going to spend about half of your life looking for where the end is. Okay. And then you will put the Kapton tape underneath the pogos. And this is to keep them in place while you do the orientation fix. Like, again, you don't have to do this. You can also just like solder everything in perfectly, but I don't. So that's that. And we'll do the microphone and speaker pogos later. Oh, man.
Hey, one request for a future show is showing the tester and EagleCAD that you made.
Yeah, I will probably do that. For this one, I was actually in a little bit of a rush, and so there was no there was no chance. But in a future one, I will probably do that.
That might be fun from the desk of Lady Ada, just showing some testers that you designed in Eagle.
I will probably show designing a tester. Okay, so this is the next step. Next step is after you do the bumpers, you do the Kapton tape. You put in standoffs, and this is, I don't remember exactly the size of these standoffs, but the point of these standoffs is the long point of the standoffs, the male thread end, goes past the pogos, but the bulk of the standoff is in between the non-springy and the springy end point. Does that make, like, there's some word, I don't know the word, but you know what I mean. It's in the middle so that when this is pressed in, it will stop it from going too far. So see how it's like it's nice and it's springy, and it hits this base before it goes through the entirety of the springiness, whatever. You know what I mean? I'm tired. Okay. And then this one's actually a little tougher because Usually I have more, I have another place I can thread, but I actually can't thread this one. But I think it's gonna be okay. And then I can do a little bit of a hack. Let's just see if this works. I'll just use some more Kapton tape. What's funny is somebody at the office labeled the bin that this goes on captain's tape, and I was like, that's way cooler. So I kind of want to call it captain's tape. Yar. Pirate tape. And I'm going to
What are the benefits to using pogo unsoldered headers instead of using soldered male-female headers?
Well, this just lets you do a temporary connection, which is kind of nice. Like I don't have to, it's a very solid but temporary connection. Okay, so hold on. So you just want to have these threaded in just like one, it's like one turn. Okay. All right, my Kapton hack is seemingly effective. Okay, maybe I need a little bit more than, yeah. Okay, so now it's kind of held in place. Now normally I have another threaded standoff over here to help, but I don't in this case. Like this is a placement hole, but it's not, there's this thing in the way and I just know it's not gonna work. But usually I have like 4 mounting holes for stuff. Like, let me see, I'll show another board and I'll explain. So for this feather, for example, I gotta remove this gently. I have 4 mounting holes, 2 over here and 2 over here, and so I could actually like screw it in, but since I don't, I'm gonna use the Kapton tape, which is fine. You know, again, it's just for the orientation. And then, I don't know if this is gonna work sideways, but basically you heat this up. I don't know if you can see, but it sort of just like snaps into place. It's kind of, it's really satisfying. Actually, this one needs a little bit of a bump. Okay. But as you heat them up, they spring, because they're held underneath, the Kapton tape underneath is keeping them from pushing back. And so when you melt it, the spring action kind of gets it to straighten out nicely.
That's a cool hack.
The only thing is that this one, I have to pull it out a little bit because it's just a little bit too offset. So what I'm gonna do, I can't do this on the overhead the way I would like to, so you guys will just have to believe me. But you hold on to it, you hold on to the head with the tweezers, and then you just pull it lightly and it will self-position. Because it only has, if it wants to straighten out, the best way to do that is to align itself so it's perfectly in the hole, because there's a little, the head is spiky, right? There's a little bit of a spike to it. So for, is this even, I guess it's close enough. The best way for it to straighten out is to orient itself to be flat.
Okay, so plated or non-plated mounting holes, and if they're plated, connected to board ground.
These are plated holes and they're not connected to ground. Because this is not high voltage and you don't have to like case ground it.
And what is the name of that tape again?
Kapton tape.
Or as we seem to be calling it, Captain tape.
Captain tape. It's also known as polyamide tape. Kapton is the brand name. I think DuPont or something came up with this brand name, and I'm okay with that. It's kind of a genericized name by now. Okay, so let's see if I can do the rest. This one is that one's a little bit too off. Okay. So I'll just snap all of these in place.
Another question is, so will the board do a self-test?
Yes. That part is done later, but yeah, it does its own self-test. Okay, those two are kind of janky.
So yeah, it's Captain trademark, and
Kapton is it trademark
by DuPont, but it's polyamide tape.
Polyamide tape, yeah. All right, this one really needs to be done by hand. Hold on. But the nice thing about it is, like, you know, I have like my soldering iron really close to the tape, And the tape don't mind. Okay, I'm gonna have to fix that one.
I believe this is the only live electronics show tonight that's showing how to build a tester for electronics.
Yes. Sometimes you gotta test yourself.
It's the only show on tonight about that.
Yeah. You have to test yourself. I'm gonna give myself a little bit of room and move it this way. Yeah, so I can see what I'm doing here. Yeah, this is so nice. They go snap, snap, snap.
Okay, here's a question.
Ooh. Okay, so they're all so nicely snapped.
So for the amateur board designers out there, should they build testers, or the advantage only that you can sell the boards afterwards?
It actually depends. So if you're manufacturing any quantity larger than 100, I would suggest making a board tester. You don't have to have a custom PCB for test. If you're selling, you really do need to have a tester, because like you really have to guarantee that what you're selling is good, because even if you have a really, really good manufacturing process, there's still always going to be some yield. Like the Adafruit yield is like 98% or so on average, which is really good. But that still means about 2% of the boards need rework, or there's something goes wrong. And by the way, sometimes the tester isn't perfect either. Like we have boards that are actually good that don't pass test because the sensitivity, or like there's like when you do testers, you'll just find out, you're like, oh yeah, like I'm too picky about how long it takes to get a cell network connectivity. Like how long are you going to wait before you consider it a failure? It can't be infinite, because eventually you have to say like, okay, it didn't pass. But there's always going to be some limit. So adjusting the testers is really important. But if you're making more than 100 of something, it's always a good idea to have some sort of test jig that you can use. And you don't have to make a custom PCB. In fact, what I've done before I did this, what I would do is I'd actually take one of these PCBs and bolt it down to a piece of perf board and use that. And you can use perf board for testing as well. If you put your test points on a 0.1 inch grid, which I would strongly recommend, if you put your test points on a 0.1 inch grid, then it's really easy to make test jigs. Sometimes you don't have a choice. Sometimes it's like, well, I kind of have to, the microphone and speaker pads here are on a 2mm grid. I just actually did not have space for them to be on a 0.1 inch grid. So it's okay, because I'm designing my own testers. If you're making your own board, just put everything on like the classic grid, and then you could just use a perf board, or like a PermaProto, or like an Arduino Shield or something to test. Okay.
I can answer the next one.
What's the next question?
Someone wants to know, do we test all the boards? Yes, we do.
We test all the boards. Every single board we make is tested.
Yeah, and that's
Sure.
one of the reasons that we're able to support over 3,000 products, although it takes a lot of time to do a full test.
Do you want me to tell you a secret? Actually, Phil, I don't even know if you knew the secret.
Yes, I would like. It's not a secret once you say it on live video to thousands of people.
So a lot of times when people are like, hey, how come? Well, okay. So when you do production management and production design, you design your board and you're like, okay, I have this many capacitors, this many placements, this kind of component, and it's double-sided, and there's a mathematical equation of like how many cents per placement, and the pitch, and the PCB size, and how many layers, and all that stuff. But the cost of test is often higher than the cost of assembly. Like I've seen this quite a bit, where assembling the board is very fast. You can always get a faster pick and place. Right, you just get one, pick and place with like 20 heads, and you have a chip shooter. You can fab a board in like 15 to 20 seconds, but the amount of like this board, like the fab time is 20 to 30 seconds, I think. Like if you just count the placement of it, and the ovening I'm going to count as like, it doesn't really count because it's a full throughput, but like maybe a minute if you include like on average. Through like taking the board, you put it through, and then you go through the oven, but the oven doesn't really count because it's running all day anyways, and that's not the bottleneck for manufacture. But to test this is going to take 2 to 3 minutes. It's going to take, and you can only really you can make multiple testers, but like you have to test each one, and you don't get the same throughput. Like it's like harder to have 15 testers because you have to like keep track of each one. So the test and prep of a product, it's not unusual for it to take longer than the manufacturing of it. or cost more because of the balance, the average time, because you can't parallel it as easily, because you still have to test each one. I mean, you can test them in bulk, but it's either way. I mean, like, not really. It doesn't always work that way. And so, especially sometimes if you have a setup where you have like one computer, and like you can only test one product per computer because of like some driver issue. So the cost of a lot of things depend on the test procedure. And when people ask me like, well, how come I can buy like an Arduino Pro Mini clone from eBay for like $2? And I'm like, well, they don't do test. They don't do tests, and so it doesn't matter. They save tons of money because they just manufacture it. And yes, there's going to be some failures in the field, but it's just worth it for them just to be like, well, you may get a bad one, but that's okay. We'll replace it or refund you. It is actually financially cheaper to replace the bad ones than to do the full test. And it's not saying that everyone does this, but it's saying if you notice that things are like really cheap, oftentimes they just skip tests. And I understand why. I'm like, that makes sense. It actually is cheaper just to replace the few bad ones than is to pay someone to test each one, because statistically speaking, they almost all work. But we do test each one anyways. So that's what it is.
Well, I think the one that you're comparing it to is eBay sellers. They may come and go, and of course it doesn't matter. Just volume. And
Yeah, you just like open up another account.
Yeah,
I'm not saying this is not always true. Many of them probably do tests, but I'm saying I know sometimes they don't. Like you get products that you're like, this was not tested.
Yeah, I mean, I think the inconvenience on the customer side is pretty high. If someone's not testing, then they might be working on something, and the timing was really required for them to have a working thing, not to wait another 6 to 8 weeks. So
yeah,
I think testing everything.
It is a trade-off. I mean, like for me, I'd rather test everything. It gives me, it helps a lot because we actually do customer support. If you don't do customer support, by the way, not that you don't have to test, but the need of testing is lower because you just replace it or refund them or whatever. But we have customers that are like, I have this setup and it's not working. Why? I can very confidently say, well, it's probably not the hardware. So let's look at your wiring, look at your soldering, let's look at what you're doing, rather than like just, we don't just replace the board, because it's like if you replace the board, it's probably not the thing that's not working. I mean, once in a while it is. It gets damaged in transit, or it's when it gets taken out of the package, maybe it gets broken or damaged or something. But it's rare. It's rare because we know each product goes through test. So we have very, very few replacements because of that.
Okay.
Okay, that's a little bit of a long rant, but it's interesting. A lot of people don't remember to account for test time when they do their pricing analysis. They just take the bill of materials and they forget. And then they're like, okay, well, it's going to cost me $2 or $3 to assemble, but they forget they have to add $2 or $3 also for the test procedure, because it takes time. You have to sit there and you have to test it. Okay.
All right, what's next?
So can we go to the hover cam? Okay, so everything is like so perfectly straight now. That's like beautiful. It's not like perfect, but it's really, really good. It's good enough that when you put this on, put this on this way, it's nice and springy, and all the pogos line up with the holes. And what's nice is when you're using these two standoffs to hook it in, and then you press it, and it all lines up very nicely. So you can push it down, do the test, and then release. So the next step is I'm actually going to remove. Oh, you know what? I have to do these 5 pogos. So let me do.
Okay. Well, here's another question. Do you assemble in panels and test the panel? Is that easier?
No, we assemble in panels. We assemble in panels. So that part, yes. Do we test in panels? No. And there's a few reasons. One, if you're going to test in panel, you might as well just make enough testers so that when you break the panel apart, you can test each one individually, because otherwise, how are you going to know which one failed? I mean, I guess there's like ways around it, but I prefer to test individually. Second, and this has happened, sometimes the act of depanelization is what damages the board. A long time ago, I had a TFT shield that, this is before the current version, and it was fixed very quickly, where there was a trace that went past a mouse bite, And once every like 200 PCBs, that mouse bite would crack the trace if it wasn't depanelized with care. And eventually, we just depanelized them with care, and then I just moved the trace and reran the boards. But sometimes, when you depanelize it, you can crack a component or you can crack a trace. And so we test depanelized. And personally, I kind of think that's the way to go. I mean, I know people say, that's not reasonable at large quantities, but I think it's fine. And I just try to make the test as fast as possible. And if parallelable, we do that.
I have a question, and then I have a comment. So the question is, have you made enough of one item to wear out a pogo pin?
Yes, we have. There's testers that have been retired. It's rare though. They last a really, really, really long time. It's a kind of impressive, actually.
And then I have a comment about the testing that we do.
Yeah.
So when we used to do kits, and then we started doing breakout boards, I think we noticed the trend. And the trend is we're starting to make little tiny supercomputers. And so eventually, if you believe that's what you're going to be doing, and you are going to do it, maybe we're going to put in a cell module, maybe it's going to be Wi-Fi, maybe it's going to be something. It's going to be super complex and basically a little tiny supercomputer.
Yeah.
Then you may as well do the right thing from the start of your endeavor and test it all at the last time it's been touched. So after it's been depanelized and all that. And I think that if you approach it that way, if you assume that like one day we're going to be making tiny MacBook Airs on it.
Oh, so cute. Oh, it's adorable.
Little tiny MacBook Airs, basically, right?
Yeah. Well, the processor that's on, the FONA is like, at Mega 334, it's like, it's kind of up there with like a Mac, the Feather, the Feather M0. It's like, it's getting up there with some like early, like Commodore 64, like processor speeds, 48 megahertz and like 32K of RAM. Like,
of course you would test, and every computer is tested. I think we all agree, every computer is tested.
Yeah, I hope so.
Yeah. I had a Dell that probably wasn't once.
Yeah.
But, so I think that's the right approach. And so if you think you're going to be able to get away with doing stuff until it works, that's sort of okay. But as someone said in the chat, good engineering is you keep at it until something fails, like you figure out what the failure is.
Yeah, designing testers actually, it's kind of what I do full time. Like I do board design, but I actually have to spend, it isn't hard, like once you have designed, I've designed like 250 testers. And so like I've gotten better at it to the point where it's like, okay, it only takes me like a day or so to design a tester. But like it's only easy because I think about it well in advance, right? As I'm designing the final board, I'm thinking like, how am I going to test all of this stuff? So like, I'd have to test the Electret microphone for this, so I have to make sure like, okay, what's the voltage range, and like, how can I, what commands do I send the cell phone module? There's a command that I found in the datasheet that lets me turn on the bias for the Electret mic without having to make a phone call. So instead of having to make a phone call with it, which is disruptive, like who would I call, and like I have to get them to pick up, and like I'm gonna call it auto service, like it's weird. Instead, there's like a command that you can say, turn on the bias. It turns on the bias, and then I can measure the bias voltage, and that's a way of testing the Electret mic connection without actually connecting the Electret. Right? There's like tricks and hacks to doing it.
One more question. What does it mean, panelized?
Panelized is, I don't have a panel here, but basically when you make this board, I don't send a board this small through the pick and place. Actually, the pick and place cannot handle a board this small. What you do is you put 10 by 5 into a grid, and then you have snap-off connectors. The PCB itself has little scores so you can snap them off. It's like, it's kind of like when you get stamps. I don't know if people even get stamps anymore, but like, let's say you got stamps. Or actually you get a chocolate bar, right? And the chocolate bar has like grids in it, and you can snap off one piece. That's basically what it is like with a PCB. There's a little scoring in it, so you can break off one piece at a time, so that you get the whole thing at once, just like you get a sheet of stamps. Like they're not going to print one stamp at a time. Like the printing press is freaking huge. They're going to print out a whole bunch and then cut them up for you. And then with stamps, they use mouse bites, what they're called. They're little grids, holes. And the holes are what makes it weak. And when you get a chocolate bar, it's V scoring. So it's a V-shaped groove that scores the circuit board and you snap it. Okay. So can we go back to the hover cam? Hover cam. Yeah, because I now have enough stuff that's not too bad. Okay, so next up, what we're going to do is we have this thing. This is a PCB clamp, and these are like the best. So this is like a little thing where you lift it and you lower it, and it's got this little rubber stopper, and these are perfect for making testers. I saw them on a couple testers that were made in China, and I'm like, I got to get those. Those are super, super sweet. And, you know, basically, it's just an easy way to clamp something down. They're called toggle clamps. That's what they're called. So we have a plate, and actually I'm recycling a Feather M0 proto plate. So these are laser cut. And what you do is you basically export the Eagle CAD file, and then you have the cutout, and then we have a standard drill pattern that matches this. You can see the drill pattern. So it matches this, and then you just, arrange the two, and then you laser cut it out. So it's kind of neat. Is actually there's a lot of technologies that are used to make testers. I once had a professional tester maker in the U.S. quote me making the Arduino Uno testers, and he very fairly gave me a quote, but it was $8,000 to make a tester for the Arduino Uno, and that was like one. And he was like, "I'm gonna 3D print stuff. It's gonna be laser cut. It's gonna be crazy." And I'm like, "Wow, that's really expensive." It was definitely a lot of his time, but I was like, well, I can probably do this myself, and we have the tools. But I was interested, what would it cost to get a professional tester made? But if you're making a product, you're only making one product, you need only one tester. For me, I need a tester every week, so I can't quite pay someone to contract with for that. Instead, we just make our own. Okay, so we've got this tester jig, and so there's these holes here, and so I'm going to keep the bumpers on because it'll keep it from sliding. And then this will, this I think aligns this way, and then I get some I think these are 440s, M4s if you're European. And then you just attach this, and I can attach it more strongly in a bit, but you just want to get it attached. Exciting tester making. And then once we make one tester, we usually I get a bunch of PCBs. We usually get like 4. Something like the FONA, I'll get 4 made because they take so long to test that you actually want to do them in parallel. Some testers we only have 2 testers worth, because they're very fast. And then this tester is actually going to use a computer. Sometimes, if possible, I try to use a standalone tester, like something that does not use a computer, so that you can have it on your desk. However, since this tester, you need to program the bootloader of the Feather FONA, you do need to have a computer involved to burn that bootloader. I guess I could use an Arduino to burn the bootloader, but I kind of just don't do that. I'm going to use a computer instead. And then this will connect over USB to the computer and spit out the self-test. So like you'll burn the bootloader through the ICSP port, and then basically this is now ready to take code through the USB port, kick the USB port, upload the test software, tell it, okay, when the test software test runs, it spits out fail or pass, and then you delete the program off of the Feather and put on like a blinking or test, something simple, so that the people who get it aren't like, oh my God, it says like fail, because it doesn't have all the pogo pins connected when they get it. Okay, so this is now mounted onto this nice piece of plastic, and then because there's some height here, and this, if you see, like this actually has to be levitated up, like this toggle clamp. So what we do is we use a 3D printer, and we could laser cut, but actually like the 3D printer works great for this. We 3D print a little shim, and it's it's like like 3/4 of an inch tall, and it has the same mounting hole pattern, and then it just lifts it to be the right height, so that it's exactly the right height, so that when you clamp down, it clamps just so it touches the pogo pins and doesn't crush or damage anything. So for this, okay, so we got these,
Okay, on a you know, who watches the Watchmen note? Who
Okay.
tests the testers? How do you know the testers are working?
that's a really good question. And there's a couple things you can do. Because it's a little uncomfortable because it's like, there is the chance that your test procedure is bad. This is actually oriented wrong. This is off by 90 degrees. So one thing we do is we have a thing called a gold sample. And the gold sample, with a sensor, let's say you have like a BMP 180. It's a sensor, and there's, it's an I2C sensor, and like it, either it works or it doesn't, pretty much, right? Like there's not a lot going on in there. So you have one tester, you have one that's exactly like perfect, and it's like, I've hand checked it, and I know that this is like the correct components and everything, and you mark it gold and you put it in a special bag. And then before you start testing, you're required to test the gold and make sure that the gold passes. Sometimes people have a fail. I don't. Maybe I should, but I don't actually. I don't use a fail product to test failure. Instead, what I do is I program the test. 99% of the tests are programmed into an Arduino microcontroller. Sorry, they're programmed into an Arduino, but I take the bootloader off. So it's programmed into the firmware without a bootloader, so I don't have to worry about the bootloader like messing anything up. And it does a little bit of like self-checking with voltages and stuff. But so far it's actually been okay. We also have a QA check for some complicated products. For example, products that have a bootloader burned in at the last step, and then a blinking something. The QA step, which is 1 out of 100 or 200 items, is somebody actually plugs in the Flora into a computer and makes sure it shows up as a Flora. So that's one way to test the tester. If you have one product, I think I would if I had one product, I'd probably think about this a lot more. But so far, I haven't really had this issue. Having golds and having multiple testers. Again, we have multiple testers, so if one goes bad, it's noticeable because it's like, hey, they're not passing. This one's not passing boards. But the most likely thing that occurs is the tester stops passing boards. I've never seen a tester accidentally pass a board, because to pass something like a BMP 180, it would have had to like fake its way through an I2C connection and measure the humidity, and it would have been correct. I mean, like it gets very complicated for it to not pass a board correctly. And I think having the test firmware burned in to a chip without a bootloader is kind of as good as it gets. I mean, like it's in there. You have the brownout fuses set. You have it perform some action at the end. So far, it's worked out. People have better ideas. Let me know. Remember, it does have to. I do have to keep the test short. But and having a fail board in addition to the gold is complicated, because how do you know that the fail is the right fail? Like there's so many ways for things to fail. When I design the tester, I do check multiple fail techniques. Like I short pans and I open some pans. I try it with the wrong module. So I do test the tester design, but I don't test each tester for fails, if that makes sense. Okay, so I've got this attached now. So this is kind of sweet, because what you do now is you can place, you hook it onto the two standoffs, and you orient it, and then you clamp, and it's like, bam! Yeah! This is so great. So this is, maybe I'll go to the overhead cam, because it's a little easier to see. So yeah, you can clamp it on. Maybe I'll tweak this a little bit. There's a little bit of tweaking with this rubber bit here, because you want to have it be straight down. So you kind of like, there's like these two hex nuts that you kind of noodle with a little bit. Let's get this oriented. Okay, that's a really good spot. and then tighten. Yeah. So yeah, that's how you do it. So now I have it on the pogo bed, and it's very easy. It's like for somebody to do test, you know, they just hook it in, clamp it down, and now you don't have to worry about like lining up all the pogo pins because these two standoffs and the pogo pins all being aligned and the clamp keep it in place. So yeah, that's good. I could give it a little bit more depth. That's it. That's kind of it. That's all I really have to show.
Okay, last question before
Yeah.
we head out, because we're at the 45-minute mark. What's the hardest type of thing to test? Microcontrollers, amplifier, sensor, cellular, Wi-Fi. What's the toughest one to
Cellular,
test?
these cellular modules are actually a total bear to test because I actually do a full, I connect to the cellular network, which takes like 20 seconds, so you have to wait for that. And you have to test the speaker and the electronic microphone, and there's like all these like DTR and RTS. I mean, I have it all now, but it took me like 2 weeks, I think, total to really nail down the tester. And then what I do is I send an SMS to a service that replies, so that I can send an SMS and then get a reply as well and verify that. I think that the toughest tester recently was the Feather M0 Wi-Fi, because you actually have to update the firmware, which only runs, the firmware updater only runs under Windows, and it's an EXE, and there's like no documentation for it, and it takes a really long time, and it sometimes fails, and like it's not clear why, and there's like 8 batch files, and like I didn't really want to rewrite the whole thing in Python, so I kind of started doing it, and then I gave up, and then I was like, you know what, I'll just like, we'll just get a Windows 10 computer. It was actually easier and overall less expensive to just get one of our computers and upgrade it to Windows 10. And have it be the test program jig, than to like try to port it to Python so we can use it on a Mac. That's what it is. And then I convinced Atmel to sell me the modules with the firmware already upgraded on them. So going forward, I will not have to do the firmware upgrade procedure, but that was really annoying. It was written for the explain board, and I was like I had to like hack it to make it work on an M0. And it did in the end. But.
And that's it for the Desk of Lady Ada tonight. Tomorrow is World Electronics Becky Stern at 2 p.m. Eastern Time. Then we have Show and Tell at 7:30 p.m. Eastern Time. Then Ask an Engineer at 8 p.m. So it's a fun day.
Tomorrow we have plenty of live shows for you too.
Tomorrow's live shows. And once again, thank you everyone out there who watches the show. Thank you all of our customers, our community. We are 100% viewer supported. In other words, when you buy a kit on adafruit.com, when you buy electronics, that is what pays the bills here. We have no loans, no venture capital, no help. We are without a net. You are our net. So
yeah.
So that's that. Tomorrow we're probably going to be celebrating a huge milestone. Watch the site. If you'd ordered recently, take a look at your order number. We're approaching a pretty big number soon. Yeah. Okay. Well,
all right. So I'm going to wrap this up. So I'm going to basically take this to a computer, and I'm actually going to basically take the Feather test code for the Feather like Ada logger and then the FONA board, and I'm just going to merge them. And I think that'll work just fine, and that'll be the test code for this this baby.
All right. Well, subscribe to the whatever channel thing that you're looking at, and hit like if there's a like or a favorite or whatever heart button there is this week. And see you online shortly, everybody.
All right. Bye, everybody.
Bye-bye.
See you tomorrow.